Welcome to the Deep Dive. We're your shortcut, really, to getting well-informed quickly without, drowning in information overload.
hmm
And today, you wanted to really get under the hood of the tech powering that TomeStackLite setup, the one live at https://tomelite.web.app.
Yeah, that's the one.
Well, that's exactly what we're going to unpack right now.
We've been looking closely at the core technologies, the stuff that made that automated deployment actually happen.
Right.
And our mission here isn't just listing tools. It's more about digging into why these specific choices, especially when you think about, well, the more traditional ways like using VMs or even Docker.
Exactly. Why this stack? So let's dive straight in. The core framework, Next.js 15, using the app router. Now, for anyone maybe not super familiar, what is Next.js in this picture?
Okay, so think of Next.js as like a complete toolkit for building web apps with React. For TomeStackLite, it handles both sides, the user interface, what you see and click on, built with React components, and the server-side logic needed to make pages load fast, handle data, that kind of thing.
Okay.
And what's key here is this version uses the app router. It's a newer way of structuring things built on React 18 and uses TypeScript too.
Right, the app router.
Oh.
So let's unpack the why then. Why go with Next.js and this specific router? What's the advantage?
Well, there are a few really good reasons. First, it gives you a really integrated development experience.
Oh, so.
Your front-end code and your back-end code basically live in the same project, often using TypeScript for both.
Oh, okay.
Which just streamlines things, helps catch errors early, makes development a bit smoother, less context switching.
That definitely sounds more efficient keeping it all together. What about actual performance? For the person using the site, that's always critical.
Oh, absolutely. And the app router is heavily focused on performance. It uses something called React Server Components.
Server components.
Yeah. The basic idea is less JavaScript needs to get downloaded by the user's browser at first, which means pages can appear much faster. It also does automatic code splitting, only sending the code needed for the specific page you're on. Plus, optimized ways to fetch data. It all adds up to, a much snappier feel.
So faster pages, less waiting, and a cleaner dev process. You also mentioned it simplifies the backend side for things like server-side rendering. How does that compare to, say, the original TomeStack? Didn't that have a separate Express server?
That's a great point to bring up. Yes, it did. With Next.js, especially the app router version, the framework itself handles a lot more of that server-side rendering work internally.
Wow.
So instead of needing a whole separate backend API just for rendering pages, like that Express app,
Right.
Next.js has built-in ways to do server-side rendering, SSR, or even static site generation, SSG. It simplifies the architecture quite a bit.
Fewer moving parts. I like the sound of that. Less to manage, less to break.
Exactly.
And there was this Firebase synergy thing. How does Next.js play nicely with Firebase?
Yeah, this is pretty cool. Firebase Hosting has this feature they call framework-aware deployment.
Okay.
Because Next.js is so popular, Firebase basically understands how a Next.js project is built and structured.
So it knows what to expect.
Precisely. When you deploy, Firebase Hosting figures out, okay, these are static files, this part needs server-side rendering, and it sets up the necessary back-end infrastructure like cloud functions automatically. It smooths out the whole deployment process significantly.
Interesting. So Firebase isn't just dumb hosting in this case. It's actively helping because it knows it's dealing with Next.js.
You got it. It recognizes the framework and optimizes the deployment for it.
Okay, so Next.js gives us the structure, the logic, the performance focus. Now, the visuals, what you actually see. React is in there, obviously, but also Tailwind CSS and something called shadcn. What are their jobs?
Right. So React is still the foundation for the UI components themselves. That reusable component-based approach we know from, even the original TomeStack discussion.
Building blocks.
Exactly. Then Tailwind CSS comes in for styling. It's a different approach. Instead of separate CSS files, you add style classes directly into your HTML, or JSX in this case.
Right there in the code. Like div class, text blue 500 font bold.
Exactly like that. It uses these predefined utility classes and makes styling really fast and helps keep things super consistent visually.
Utility classes. What's the big draw there compared to writing regular CSS?
Speed is one thing. Consistency is another big one. You're using a defined set of utilities, so you avoid lots of custom CSS that can get messy over time. And often, the final CSS bundle sent to the browser is smaller too, which helps performance again.
Okay, rapid, consistent styling. And then shadcn. That name might be new to some listeners. What does it do?
So shadcn is basically a collection of pre-designed, accessible UI components. Think buttons, dialogues, forms, menus, the common building
Like a
blocks.
component library? Bootstrap or Material UI, maybe?
Sort of, but with a really key difference. With most libraries, you install them as a dependency and import the pre-built components. With shadcn, you don't install a library. You actually use its command line tool to copy the source code of the component you want directly into your own project.
Wait, hang on. You copy the actual source code, not just import it.
Exactly. The raw source code for, say, the button component gets added right into your code base.
Why would you do that? What's the benefit?
Total control. Because it's your code now, you can change anything about it, the styles, the behavior, anything, without fighting the library's opinions or limitations. Plus, you only bring in the code for the components you actually use, so no extra bloat.
Huh. That is different. Maximum flexibility, minimal dependencies. I can see the appeal.
It's a very deliberate choice, yeah. Focused on control and keeping things lean.
Okay, so Next.js for the frame, React for components, Tailwind for fast styling, shadcn for customizable base components. Makes sense. Now, where does this all end up living online? Firebase hosting, you said. But it sounds like maybe there's more to it than just hosting.
That's absolutely right. Well, Firebase hosting is kind of the front door, the thing you interact with directly for deployment. It's under the hood, especially for a dynamic Next.js app using the app router. Firebase automatically pulls in other Google Cloud services.
Like what?
Specifically for running the server-side code, those React server components we mentioned, it uses cloud functions, the newer Gen 2 functions, actually.
Okay.
And those Gen 2 functions actually run on another service called Cloud Run. Firebase also uses Cloud Build to create the necessary container images for those functions and artifact registry to store those images.
Wow, okay. So deploying to Firebase hosting actually spins up Cloud Functions, Cloud Run, Cloud Build. It's orchestrating a whole bunch of Google Cloud stuff behind the scenes.
Precisely. Firebase hosting handles the static files and the routing, but for the dynamic parts, it intelligently provisions and manages these other more powerful backend services for you automatically.
Okay, so why this Firebase Google Cloud route instead of, firing up a virtual machine on DigitalOcean like in the original TomeStack?
Yes.
What's the payoff?
The biggest reason is it's a managed platform, passes platform as a service, meaning Google Firebase handles all the infrastructure grunt work, the servers, making sure it scales up if you get lots of traffic, the CDN for speed, SSL certificates for security, all that stuff you'd normally have to set up and maintain yourself on a VM.
Yeah, the sysadmin stuff.
Exactly. Firebase handles it. You, the developer, just focus on your code. It's a huge reduction in operational headache.
Fewer headaches, always good.
Definitely. And remember that framework-aware deployment, that's another massive plus. Once it's set up, the Firebase deploy command, or the automated version we'll get to, looks at your Next.js project, builds it correctly, uploads the static bits to hosting, provisions, and deploys the cloud function or cloud run service for the server-side parts, and sets up the routing rules and hosting to direct requests properly.
Wow. So one command really does handle deploying both the front-end static stuff and the dynamic back-end pieces.
That's the magic of it, yeah. It figures it all out.
That sounds incredibly streamlined compared to managing separate front-end and back-end deployments.
It is. And beyond just deployment ease, you get the robustness of Google Cloud. Easy access to other Firebase services later if you need them, like authentication or databases. And that automatic scaling from Cloud Functions and Cloud Run is built in. If your app suddenly gets popular, it should handle the load without you needing to manually resize servers.
Okay, managed infrastructure, simplified deployment via framework awareness, auto-scaling. It paints a pretty compelling picture. Now, the automation piece. GitHub Actions. How does that fit in?
Right. GitHub Actions is built right into GitHub. It lets you automate workflows based on events in your repository, like pushing code. In this setup, there's a file, that GitHub workflows deploy.uml. This file defines a workflow, basically a script, that automatically builds and deploys TomeStackLite whenever code gets pushed to the main branch.
So every time we merge an update to main.bang, it deploys automatically.
Exactly. No manual deployment steps needed after a merge. It makes deployments consistent and reliable, reducing the chance of, someone forgetting a step or doing it wrong. Human error.
Peace of mind, basically. Can you walk us through the main steps in that deploy.mml workflow? What does it actually do?
Sure. First, it checks out the latest code from the main branch. Simple enough.
Okay.
Then it sets up the correct version of Node.js, the one the project requires. critical for consistency.
Right.
Then, and this is important, it installs the project dependencies using npm shy.
npm shy. Not just npm install. Why the difference?
npm shy is generally more reliable for automated environments like this. It does a clean install based exactly on the package-lock.json file. npm install can sometimes update minor versions, which could potentially introduce unexpected changes. Shy guarantees you get the exact same dependencies every single time.
Okay. Predictability. Makes sense for automation. What next?
After dependencies are securely installed, it runs the build command for Next.js, which is typically npm run build.
Okay.
This compiles everything, optimizes the assets, gets it ready for production. Then it needs to authenticate with Google Cloud so it has permission to deploy.
How does it do that securely?
It uses a Google Cloud service account. You configure GitHub Actions with credentials for the service account, which has just enough permission to deploy to Firebase and related services, no personal passwords involved.
Good. Secure.
Yeah.
And then the final step.
The final step is actually deploying using the Firebase command line interface, the CLI. The command looks something like npx Firebase tools deploy force, or similar. And as we discussed, that single command tells Firebase to deploy both the static hosting assets and the necessary cloud functions run backend service.
So it's check out, set up node, install dependencies reliably, build the app, authenticate securely, and then deploy everything with one Firebase command.
That's the flow. Completely automated, triggered just by pushing code. It's a standard practice in modern web development for a reason.
Absolutely. Save time, reduces errors. Okay, and just briefly, the dev tools mentioned. VS Code, Git GitHub, WSL2. These are pretty standard, but why highlight them here?
Well, they're standard because they work really well together. VS Code is just a fantastic, versatile code editor with great support for JavaScript, TypeScript, React, right, everything used here. Git and GitHub are obviously essential for version control, collaboration, and hosting the code that GitHub Actions watches.
Right.
And WSL2, the Windows subsystem for Linux, is a big deal for developers on Windows. It provides a real Linux environment inside Windows.
Why is that helpful?
A lot of deployment targets and command line tools work best, or are designed primarily for Linux. WSL2 gives Windows users a seamless way to use those tools and have a development environment that closely matches the production environment, say, on Cloud Run. The integration between VS Code and WSL2 is particularly smooth these days.
Okay, so making the developer experience comfortable and consistent across different operating systems.
Exactly. It's about having the right tools for the job, and these are, well, pretty much the industry standard choices for this kind of development.
All right. So we've covered a lot. Next.js is the full stack framework. React, Tailwind, shadcn the front end, Firebase hosting, but really leveraging Google Cloud underneath for scalable deployment. GitHub Actions automating that deployment, and the standard dev tools making it all happen. It really feels like these weren't just picked randomly, but chosen specifically to work together.
Absolutely. There's a clear synergy. Next.js is built with deployments like this in mind. Firebase is optimized for frameworks like Next.js. GitHub Actions ties it all together for reliable delivery.
Yeah.
And compared to, managing VMs or Docker setups yourself, this whole approach really shifts the burden. Less focus on infrastructure management, more focus on actually building the application.
Which is the goal, right? So thinking about this modern integrated way of doing things, it does make you wonder, doesn't it? Where else could this level of automation and platform integration really change the game? Maybe even for internal tools or other projects people are working on.
That's a really good question to ponder. I mean, when the platform handles so much of the underlying complexity, scaling, deployment, infrastructure, it genuinely frees up developer time and brain power.
Right.
What new features could you build? How much faster could you iterate if you weren't bogged down managing servers? It unlocks possibilities that might have seemed too cumbersome before.
Definitely food for thought. Well, this has been a fascinating deep dive into the tech behind TomeStackLite. Seeing how these pieces interlock is really quite illuminating.
Glad we could unpack it.
For everyone listening, maybe this sparks some ideas. Perhaps you're now curious about the nitty-gritty of that deploy.eml workflow, or exactly which Google Cloud services get spun up automatically. These could definitely be topics for future deep dives.
Absolutely.
Thanks for joining us today. We hope this gave you a much clearer picture of TomeStackLite's technical foundation.